Attention! This video is made for scientific and educational purposes. The video does not violate YouTube's rules. Link to the document with links to the original video and quotes in the description. Hi. Today we will tell you about the Boeing X-37, also known as the Orbital Test Vehicle (OTV). Officially, the X-37 is not a weapon or military development. But this is official, and as you know, official information is not always true. Anyway, this topic is quite interesting and that's why we made this video for you. If you are also interested in this topic, let us know in the comments. And tell us what you think about the true purpose of the X-37 and other modifications that we will talk about later. We remind you that this video is of a scientific and educational nature and does not violate the rules of YouTube. Link to the document with links to all video sources and quotes in the description. The Boeing X-37 is a reusable robotic spacecraft. It is boosted into space by a launch vehicle, then re-enters Earth's atmosphere and lands as a spaceplane. The X-37 is operated by the United States Space Force for orbital spaceflight missions intended to demonstrate reusable space technologies. It is a 120% scaled derivative of the earlier Boeing X-40. The X-37 began as a NASA project in 1999, before being transferred to the United States Department of Defense in 2004. The X-37 first flew during a drop test in 2006. Its first orbital mission was launched in April 2010 on an Atlas V rocket, and returned to Earth in December 2010. Subsequent flights gradually extended the mission duration, reaching 780 days in orbit for the fifth mission, the first to launch on a Falcon 9 rocket. The latest sixth mission launched on an Atlas V on the 17th of May 2020. In 1999, NASA selected Boeing Integrated Defense Systems to design and develop an orbital vehicle, built by the California branch of Boeing's Phantom Works. Over a 4-year period, a total of $192 million was spent on the project, with NASA contributing $109 million, the U.S. Air Force $16 million, and Boeing $67 million. In late 2002, a new $301 million contract was awarded to Boeing as part of NASA's Space Launch Initiative framework. The aerodynamic design of the X-37 was derived from the larger Space Shuttle orbiter, hence the X-37 has a similar lift-to-drag ratio, and a lower cross range at higher altitudes and Mach numbers compared to DARPA's hypersonic technology vehicle. An early requirement for the spacecraft called for a total mission delta-V of 7,000 miles per hour, 3.1 kilometers per second for orbital maneuvers. An early goal for the program was for the X-37 to rendezvous with satellites and perform repairs. The X-37 was originally designed to be carried into orbit in the cargo bay of the Space Shuttle, but underwent redesign for launch on a Delta IV or comparable rocket after it was determined that a shuttle flight would be uneconomical. The X-37 was transferred from NASA to the Defense Advanced Research Projects Agency (DARPA) on 13 September 2004. Thereafter, the program became a classified project. DARPA promoted the X-37 as part of the independent space policy that the United States Department of Defense has pursued since the 1986 Challenger disaster. As we said earlier, the purpose and tasks for which the U.S. Air Force uses an orbiting aircraft are not disclosed. Officially, the U.S. Air Force states that the main tasks of the X-37B are reusable spacecraft technologies, as well as experiments that can be returned to Earth. When it was first launched in 2010, it was believed that, according to the official version, its main function would be to deliver cargo to orbit. According to other versions, the X-37 will be used for intelligence purposes. According to the Russian writer-historian Alexander Shirokorad, expressed in 2010, the above assumptions are untenable due to economic impracticability, and the most plausible purpose of this device is to run in technologies for the future space interceptor, which allows you to inspect other space objects and, if necessary, disable them by kinetic impact. And this purpose of the device is fully consistent with the document National Space Policy of the United States of 2006, which proclaims the right of the United States to partially extend national sovereignty to outer space. In January 2012, it was suggested that the X-37B OTV-2, which had been in orbit since March 5, 2011, was used to track the Chinese Tiangong-1 module launched in September 2011. However, analysis of the spacecraft's orbit showed that it never came close enough to the Chinese spacecraft to make the observation meaningful. Now let's hear what the Russian military says about the X-37. Anatoly Sitnov from 1994 to 2000, Chief of Armament of the Armed Forces of the Russian Federation. Anatoly Sokolov from 1991 to 1998, Commander of the 3rd Separate Special Purpose Missile Warning Army. Video fragments are used as quotes. "We can't oppose this system now. And when it was announced that he was in space for 270 days, it means a raised sword over the head of any state where he will be hanged. It's hard to shoot it down because it doesn't fly in fixed orbits. And any change in the orbit of the transition from one to another is almost impossible to do to fight it. It is seriously manageable. It is under constant management. Its high autonomy and, in my opinion, probably very high selectivity of purpose allows it to enter a new class, which we still find difficult to imagine for ourselves. Which can solve not only global problems. On this scale, I think it is necessary to monitor and control the governments of countries. This object can carry the system of organization and management of space weapons. That is, creating, managing groups, a group of satellites, ensuring the creation of, let's say, plasmoids or something that forms a lens and everything else. Neither China, nor Russia, nor the United States itself have the means to counter this type of weapon. There are a lot of reasons why we don't have this. But first, because no one in the country is engaged in this branch of military use of space vehicles. On your screens is a list of X-37B space missions. As of October 2019, the 2 operational X-37Bs have completed 5 orbital missions. They have spent a combined 2,865 days, 7.85 years, in space. The first X-37B launched on its first mission, OTV-1 USA 212, on an Atlas V rocket from Cape Canaveral Air Force Station, Florida, on the 22nd of April 2010 at 23:52 Coordinated Universal Time. The spacecraft was placed into low Earth orbit for testing. While the U.S. Air Force revealed few orbital details of the mission, a worldwide network of amateur astronomers claimed to have identified the spacecraft in orbit. On the 22nd of May 2010, the spacecraft was in an inclination of 39.99 degrees, circling the Earth once every 90 minutes on an orbit 249 by 262 miles, 401 by 422 kilometers. OTV-1 reputedly passed over the same given spot on Earth every 4 days, and operated at an altitude that is typical for military surveillance satellites. Such an orbit is also common among civilian LEO satellites, and the spaceplane's altitude was the same as that of the ISS and most other crewed spacecraft. The U.S. Air Force announced the 3rd to the 6th of December landing on the 30th of November 2010. As scheduled, the X-37B was deorbited, re-entered Earth's atmosphere, and landed successfully at Vandenberg AFB on the 3rd of December 2010, at 9:16 Coordinated Universal Time, conducting the first U.S. autonomous orbital landing onto a runway. This was the first such landing since the Soviet Buran shuttle in 1988. In all, OTV-1 spent 224 days and 9 hours in space. OTV-1 suffered a tire blowout during landing and sustained minor damage to its underside. The second X-37B launched on its inaugural mission, designated OTV-2 USA 226, aboard an Atlas V rocket from Cape Canaveral on the 5th of March 2011 at 22:46 Coordinated Universal Time. The mission was classified and described by the U.S. military as an effort to test new space technologies. On the 29th of November 2011, the U.S. Air Force announced that it would extend USA 226 beyond the 270-day baseline duration. In April 2012, General William L. Shelton of the Air Force Space Command declared the ongoing mission a spectacular success. On the 30th of May 2012, the Air Force stated that the X-37B would land at Vandenberg AFB in June 2012. The spacecraft landed autonomously on the 16th of June 2012, having spent 468 days and 14 hours in space. The third mission and second flight of the first X-37B, OTV-3, was originally scheduled to launch on the 25th of October 2012 but was postponed because of an engine issue with the Atlas V launch vehicle. It was successfully launched from Cape Canaveral on the 11th of December 2012 at 18:03 Coordinated Universal Time. Once in orbit, the spacecraft was designated USA-240. Landing occurred at Vandenberg AFB on 17 October 2014 at 1624 Coordinated Universal Time, after a total time in orbit of 674 days and 22 hours. The fourth X-37B mission, OTV-4, was codenamed AFS-PC-5 and designated as USA-261 in orbit. It was the second flight of the second X-37B vehicle. The X-37B launched on an Atlas V rocket from Cape Canaveral Air Force Station on 20 May 2015 at 15:05 Coordinated Universal Time. Objectives included a test of Aerojet Rocketdyne's XR-5A Hall effect thruster in support of the Advanced Extremely High Frequency Communications Satellite Program, and a NASA investigation on the performance of various materials in space for at least 200 days. The vehicle spent what was then a record-breaking 717 days and 20 hours in orbit before landing at Kennedy Space Center's Shuttle Landing Facility on 7 May 2017 at 11:47 Coordinated Universal Time. The fifth X-37B mission, designated USA-277 in orbit, was launched on 7 September 2017 at 1400 Coordinated Universal Time, just before the arrival of Hurricane Irma. The launch vehicle was a Falcon 9 rocket flying from Kennedy Space Center Launch Complex 39A, and number of small satellites also shared the ride. The spacecraft was inserted at a higher inclination orbit than previous missions, further expanding the X-37B's envelope. During the flight, the spacecraft modified its orbit using an onboard propulsion system. While the complete payload for OTV-5 is classified, the Air Force announced that one experiment flying is the Advanced Structurally Embedded Thermal Spreader 2 (ASETS-2), which measures the performance of an oscillating heat pipe. The mission was completed with the vehicle landing at the Shuttle Landing Facility on 27 October 2019 at 7:51 Coordinated Universal Time. The sixth X-37B mission, OTV-6, U.S. Space Force 7, formerly known as AFS-PC-7, launched on an Atlas V-501 rockets, from Cape Canaveral Air Force Station, SLC-41 on 17 May 2020 at 13:14 Coordinated Universal Time. The mission hosts more experiments than prior X-37B flights, including 2 NASA experiments. One is a sample plate evaluating the reaction of select materials to conditions in space. The second studies the effect of ambient space radiation on seeds. A third experiment designed by the Naval Research Laboratory (NRL) transforms solar power into radio frequency microwave energy, then studies transmitting that energy to Earth. The X-37B remains a department of the Air Force asset, but the newly established U.S. Space Force is responsible for the launch, on-orbit operations, and landing. Once in orbit, the X-37B also will release a small satellite, of 136 kilograms (300 pounds), named FALCON-SAT-8. Developed by Air Force Academy cadets in partnership with the Air Force Research Laboratory (AFRL), the small satellite carries 5 experimental payloads. The spacecrafts will test a novel electromagnetic propulsion system, low-weight antenna technology and a commercial reaction wheel to provide attitude control in orbit. The schedule for the deployment of the FALCON-SAT-8 spacecraft from the X-37B spacecraft remains fluid, and may be days, weeks or months. Thank you for watching this video to the end. We hope that you liked it. If we are right, then like this video and share it with your friends on social networks. Well, we'll see you soon in new videos.